Hello, geometry students. Welcome to today's lesson. Today we are going to be learning about distance and midpoints. So please write that down. This is our lesson topic. Our lesson objectives today are to find the distance between 2 points and find the midpoint of a segment. So we're going to go over how would we find this point, how do we find the distance between 2 points, and also finding the midpoint of a segment. So go ahead and write those down as our lesson objectives. So we have this problem here, and we need to find the distance between 2 points. So we have here a number line. We have 0 up to 7 and -7. And we need to find the distance between B and E. So that's the length of segment BE. So we have B here. And we have E here. And on a number line, it's pretty simple. We can intuitively see that the distance from B and E, so BE, is going to equal the difference between them. And we can even just do this mentally, since we know that E is at +2 and B is at -6. We see that when we go 2 minus -6, we equal 8. So the difference is 8. But can we come up with maybe a formula so that we can always come up with the same points when things get a little bit more complicated? So take a moment and think to yourself and write down what you think would be a good formula for finding the distance on a number line. So if we have 2 points, P and Q, their distance is going to equal the absolute value of x2 minus x1. So go ahead and put this formula into your glossary for the distance formula on a number line. So when we're finding the distance on a collinear points, which is what we learned about here. Now, obviously, the world is not in just one dimension, and so now let's try to find the distance between 2 points on a plane. If we look at this, what do we notice? If we look, we can see actually that we are going to apply the principle, the Pythagorean theorem principle here. And so we'll end up with, if we dot this down here, we have 2 sides of a triangle. And so to find the hypotenuse, remember we do a squared plus b squared equals c squared. And so if we need to find our distance here, we can find the difference between x1 and x2 and y1 and y2 to find our total distance. So we get a formula of PQ is equal to square root of x minus x1 squared plus y2 minus y1 squared. So this is y1, y2. This is x1, x2. So again, you can write this formula down in your glossary under the distance formula in a coordinate plane. So when we're thinking about it in 2 dimensions, this is our formula. And we're going to use this formula a lot more than we would in just the number line. But you can use this formula even if it is on a number line. For example, if y1 and y2 are 0, then this simply just cancels out and you're left with square root. Oh, that does not show up, sorry. The square root of x minus x1 squared, which equals, once you cancel out the square and square root, x squared minus x1 So an example, finding the distance between 2 points on a plane. So we have here C, which is -4, -6. Since I don't have this on my graph, I'm going to make this positive. So we're at 4, 6, and 5, -1. So I want to find the distance between these 2 points. So we have C, which is equal to x1, y1, 4, 6. And we have D, which is equal to x2, y2, so now if we use our formula, CD is equal to square root of x2 minus x1 squared plus y2 minus y1, which is 6 squared. You end up with 1 squared plus -1 minus 6 is -7 squared. When we square a negative number, we end up with positive. So we get square root of 1 plus which equals square root of 50. We can simplify this if we'd like to 7.07, which is equal to CD. Now we can go back and check our answer by looking here. We have our difference in y and our difference in x. You'll notice again that this is very similar to the Pythagorean theorem. If this would be b squared, a squared, and c squared. Our distance formula follows a similar pattern, and we see that our answer is logical, that 7.7 or 0.07 makes sense. Moving on, we're going to learn about the midpoint of a segment. So the midpoint of a line segment, again, can be found relatively easily. Here we have x1 and x2, and if we're looking for the middle of it, we add x1 and x2 and then divide by 2. Let's look at this example here. So we have Jacinta, who hangs a picture that is 15 inches from the left side of the wall. How far from the edge of the wall should she mark the location for the nail? The picture will hang on the right side edge is 37.5 inches from the wall's left side. So we have 15 inches. Between here and here. And then we have, sorry about that squiggly line, 37.5 inches. So again, if we want to find the midpoint, so the picture will hang straight and be where we want it to be, we're going to do x1 plus x2 divided by 2, which is equal to 15 plus 37.5 divided by 2, which is equal to 52.5 divided by 2, which is equal again to 26.25. Again, let's take this a step further and finding the midpoint on a coordinate plane. So our formula for the midpoint is going to be similar. So to finding the x coordinate of the midpoint, we do what we'd use for the formula for a line. But since we have a y component of it now, we need to do that as well. So for example, we have this line here, this line segment PQ. We want to find the midpoint M. So we have x1, y1 for coordinate P, and we have x2, y2 for coordinate Q. If we want to find the midpoint, we're going to use x1 plus x2 divided by 2 for the x coordinate, and we're going to use y1 plus y2 divided by 2 for the y coordinate. So let's try a practice problem with this. So find the coordinate M and the midpoints of S and T. For S is -6, 3. So -6, 3 is S, and 1, 0 is T. So go ahead and try this on your own. All right, let's solve this together. So we have this line segment that we're looking to find. So our formula for finding the midpoint is going to be M x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. All right, so what is our x1 and our y1? So S equal to x1, comma, y1, -6, 3, and T is equal to x2, y2, which is equal to 1, 0. So now we just plug it in. x1, -6 plus 1 divided by 2, comma, 3 plus 0 divided by 2. Our midpoint is going to be -5/2, comma, 3, 2. So if we look for this, -5/2 is going to be -2.5. And 3/2 is 1.5. So here's our midpoint. let's do one more example here. This time we're going to be using algebra. So point M is on the midpoint of line segment CD. What is the value of A in the figure? So you see here, we're looking for A, which is part of the coordinate for point C. We know the midpoint, and we know point D, but we need to find what is the coordinate for C so that we can find out what the value of A is. So again, we have our formula. Midpoint is x1 plus y1 over 2, comma, y1 plus y2 over 2. We know our second coordinate, since we know D is equal to x2 comma y2 is equal to 9 comma 2. And we know our midpoint is equal to 6 comma 4. But now, how are we going to solve for our C? So we need to find C. We know that C is equal to x1 comma y1. So go ahead and try and solve this in your notes before moving on. So let's split this up into our x and y coordinates. So here we have, under the x column here, x1 is equal to A, x2 is equal to, this should be x2, not y2. Sorry for that. So we have x2, which we know is 9, and we have m, which is equal to 6. So our formula here for the x component is going to be 6 is equal to A plus 9 over 2. So now if we can simplify this to solve for A, multiply both sides by 2. Sorry, these cancel out. We get 12 is equal to A plus 9. And 3 is equal to A. So we know part of C, so we know that C is equal to 3, comma, but now we need to find 2A, which is 2 times 3 is equal to y1, and so 6 is equal to y1. So the point is 3 comma 6. And A is equal to 3. One last vocabulary word that we're going to talk about, is the segment bisector. So we learned about bisectors last lesson. We learned about angle bisectors. And like angle bisectors, segment bisectors are a line or plane that intersect the segment at its midpoint. Midpoint there. So in figure M, in the figure we have M is the midpoint of it all. And we have the plane A. This is plane A here. We have line MJ, KM, segment MJ, line KM, and the point M there are all bisectors of PQ. So PQ is our main line. They all intersect PQ at its midpoint, which is M. So we say that they bisect PQ. So we have our points, our plane, our line, our segment and our line all bisect PQ at its midpoint M. That is it for our lesson for today. Please go ahead and begin practice problems on PowerSchool Learning. If you have any questions, jump back into the Zoom call and contact Mr. Schuessler. Also, before you leave today, go back to the GeoGebra activity that we did on lesson 1 and check if you have any comments from me. So I graded those all, and if you have comments, please read those comments and redo the GeoGebra activity. So go ahead and check that before you finish today's lesson. You can either do it before you work on the worksheets or after, but please make sure that you remember that. Thanks for listening.